Okay, so okay, I need to share my screen. Okay, guys, I want to believe, I think in a few, my screen will be up. Okay, and believe now it's up. Is it up already? Is it up or not yet? Thank you. Thank you for that. Now, I'm just sharing, what I want to believe all those who have been enrolled are seeing on their portal. And, there are a lot of material actually that you can, get from this portal of yours, including the labs. So for people who have been asking, how do they access the labs, then you can get the labs in some of these modules. So not all modules will have the labs, but some of those modules, you'll find that they have the labs. Like, for example, if I click on this module 2, so if you scroll down, okay, if you scroll down, okay, if you scroll down, in these sub-modules, you'll find that there are some lab activities. Not only that, there's actually what I call in syntax checker, also, which is provided to enable you interact with this simulation. Okay, so here we don't have any. Let me check on this iOS navigation. Yeah, in this iOS navigation, you'll find that do you have any packet trace activity? No, we don't have any packet trace activity here, but I can see we have we have syntax checker. The one written syntax checker. Syntax checker provide you with a platform where actually you can now demonstrate, okay, or practice your configurations. Of course, using the instructions that have been provided. So that means you don't have to load the packet tracer for you to be able to use this. It's just syntax checker, and you can see basically what they're talking about. Okay, so use the syntax checker activity to navigate between the iOS command lines on a switch. So syntax checker is provided there, guys. So here, what do they want you to do? So to enter the privilege mode, using you have been told the command is enable. So it's just a faster way of practicing again, not necessarily without opening the packet tracer, but still you need the packet tracer for more advanced, activities. So here I just type enable, okay? And with the syntax checker, by the way, you must provide the full commands. There's no shortcut. Shortcuts are only applicable within the packet tracers, but not within the syntax checker. So for example, if I type en and enter, you see the message that I'll get. You must enter the exact and full command, enable. So meaning you have to type that enable command, the enable command, okay, then enter. The moment you enter that, okay, they'll give you the next instruction, what you're supposed to do. Return to user executive mode using the disable command. So you type disable. disable. Okay, then it will take you back, can see, to user what? To user mode. Again, re-enter privilege executive mode. Of course, that one you had type using the enable command. The enable command. So as you can see, you cannot scroll up in this syntax checker. So at least get that time, navigate through it using the full commands there. Then enter global configurations mode using the configuration terminal. So you type configure terminal, okay, enter, okay, exit global configuration mode and return to privilege mode using the exit command. You type exit command, okay? So you're just practicing, and especially for the beginners, who are still learning some of the basic things. So the syntax checker is good for you. Then re-enter global configuration mode. So of course that one again, I have to type configure terminal are there. You enter. Then enter line subconfiguration mode for the console port using the line console 0 command. So while there, type line console 0, enter. Okay, then return to global configuration mode using the exit command. You type exit, okay. Enter VTY line, that is the virtual terminal line subconfiguration mode using the line VTY 0 to 15. So there you type line VTY space 0 to 15. Okay, line VTY space 0 to 15. There you go. You are. Then return to global configuration mode. Okay, how do you return? Exit command being used here. Okay, enter the VLAN1 interface subconfiguration mode using the interface VLAN1 command. Okay, so you have interface VLAN1, interface VLAN1. Yes, there you are. Then you're being told from interface configuration mode, from interface, underline the word, from interface configuration mode, switch to line console subconfiguration mode using the line console 0. Okay, you switch to it. So meaning they're telling you, you don't have to go back to global mode to have line console. Okay, 0 configurations. It means you can still do it while on this sub mode of the interface mode. So that's what they're saying, from interface configuration mode, switch to the console sub configuration. So there you type line console 0. While on that sub interface of the VLAN, okay, you can switch while inside there. Okay, yes, there you are. Then the next instructions they're giving you, return to privilege executive mode using the end command. You type end command. You see, as long as you are doing the right thing, you'll get the next instructions. If you don't do the right thing, it will just stuck there until you get the right thing, then you move on. Okay, then you can see at the end of it all, you successfully navigated between the various iOS command line mode. If you scroll down, you see down here, maybe if you are really stuck and you are struggling the kind of command you don't understand, you can see, show me, okay? The part that you cannot maybe interpret correctly. So it will actually give that command, the one which you're supposed to type there. Or if you have show all, it will actually display everything. But you just want to, without referencing, you just want to practice until you get perfect, but to see, okay, whether you are doing the right thing. So syntax checker is good for you guys. I hope this one is very interactive. Okay. Still, I will take you through the labs, they're there, don't worry. Let's look at the command structure. Now with the command structure, okay. Yeah, you can see, okay, this is a video for syntax checker. Command, this IS command syntax check, okay, not that one. You see, this a lab here. The one written packet tracer. You see that those are the labs. The one written packet tracers, those are the labs. You just need to click on it. Then now, if you click on it, this is the page you'll get. This navigate the iOS. This is the PDF part of it. Okay, it is the PDF with the instructions. This is the PDF, but the other one is now the PT itself, which you can download. As long as you have installed the packet tracers, then you can go ahead and download this. You are, okay, and there you are. You can see it is here. You have downloaded your packet tracer. So now these packet tracers of yours will just come with, okay, this is within the download. So if you click on it, these packet tracers of yours, actually it will open for you. It will open for you the activities that you're supposed to perform there. Okay, just give it a few minutes. It's coming up. So now what you can do, you can have or create a folder. Then in each module, you can check the packet tracers activities. Then you download them and save them within one folder so that at your free time, you can just be practicing using these PTs, because you can do it while offline. Okay, all the PTs except the syntax checker. Syntax checker, you have to be online, because that one, you see, it just provides you with that particular app platform. I don't know why it's taking longer to launch it. I believe it's still coming up. If you move to basic device configurations, okay, the rest are just notes. Okay, as you can see, the notes and what, explaining everything, or things that already you have covered. You see, we have all this, the likes of passwords, configurations, etc. All this. Okay, everything is here. Okay, my PT is there opening. The banner messages and what have you. Okay, everything is here, including the video. The video, secure administrative access to a switch. So the video also, that guy will actually be explaining for you everything. So it's a video. So you can even, play the video. Okay, because the video will have everything.
So only be able to access it and make changes. We'll need to perform some initial configuration settings. I'll click on PC1.
Is sound there? Is sound there? Oh, thank you for confirming. So it means you can make use of videos as well. You can play the videos. Also, videos will be demonstrating some of those configurations are there for you guys. Okay. Then I can stop this video. Then you have syntax checker again coming in. Syntax checker. And within the syntax checker, basic device configurations, what are you supposed to configure? So they have lined up all these activities that you're supposed to configure. Secure management access to a switch, assign a device name, secure use executive mode access, secure privileged executive mode access, secure VTY access, encrypt all plain text passwords, display, a log in banner message. So all these are supposed to be, performed within the syntax checker. So the first thing you're being told, enter global configuration mode. So configure terminal. Okay, configure terminal, as we have said there. Okay, you enter. Then you're being told name the switch as this. So host name. Then remember it is case sensitive, the name. So SW, is W capital? No, small letter. Small w dash floor capital F. Okay. Then 1, enter. As long as you have done the right thing, it will give you the next instructions, what you're supposed to do. Secure use executive mode access by entering the line console, assign the password Cisco, enable login, and return to the global mode. It's very simple, the way actually you have been doing it. So while there, line, let me just complete this part, then you can proceed to something else. Console 0, enter. Then password here, they're saying assign the password Cisco. So password, password Cisco, enter. Then enable login, so you type login command, enter. Then and return to the global mode using exit, then you type exit command. You see? So syntax checker is a very interactive platform, okay, up there that you can always make use of, okay. Then also you'll find that there are check your understanding, okay, on that particular subtopic that you have gone through. You can just, scan through those questions that are there. Check your understanding, basic configurations. So usually with check your understandings, you just get few questions. They're not that much. Okay, the exam consists of 5 questions and 70% is required to pass. You have unlimited attempts. So it means with the checkpoint, you can, repeat, have several attempts the way you want. You have no limit or time limit per the attempt to pass this exam. That is check your, check your understanding. So if you just click start, then some of those things you have been practicing. So you are being asked, what is the command to assign the name? Okay, this one, SW flow to a switch. What is the command? Okay, so which one is that? Now that you guys have interacted with this and you have done it severally, what is that command? The first one, correct? This one here. Okay, then you go down and submit here. Okay, you submit here. Okay, that is, it will take you to the next question. What is the privilege executive mode access secured on a switch? What is the privilege mode access secured on a switch? Is it service password encryption? Is it secret class? Is it enable class? Enable secret class? Which one? Which one, guys? Which one? Option 4, that is the last one. 1, 2, 3, 4. Yeah, the last one. So this one here. Okay. Okay, submit. Okay, then which command enables password authentication for user executive access on a switch? Okay. Which command enables password authentication? Okay, Linda, yes. Login. Okay. Login. Yes. Bolton, yes. Then submit. Which command encrypts all plaintext password access on a switch? Access on a switch. Which command encrypt all plain text password access on a switch. Which one is that? Option 4, option 4. Okay, the last one, 1, 2, 3. Yeah, this one here. Okay, then submit. One more questions. There were 5 questions, remember? Then finally, which is the command to configure a banner to be displayed when connecting to a switch? Okay, which is the command? Okay, okay, guys are saying option 1. Let me just go with the option 1 as they have said. Okay, oh good. Okay, then submit, okay, then here, are you sure you want to submit the quiz? You can, yes, confirm this. For the submit button to be active, you have to confirm, then submit. Then what you'll get is this, you have scored 100%. Congratulations, you have passed the exam. For this, remember, they're just what? They're just check your understandings for some, as you'll be able to get them as you go through. Okay, so you might find that this was under 2.4 basic device configurations. You get that check your understanding. You have syntax checker as well. Okay, now I talked of how do you call it, checkpoint exams. Okay, let me go back a bit. I talked of checkpoint exams here. You see here. Now the reason why those check your understanding that you have completed with those few questions, like 5 questions, some will get with 4 questions, some will get with 2 questions or 3 questions, depending with how it has been set. For each module that you have those check your understanding and syntax checker that you can perform, then those check your understandings, those questions that you are doing are the one combined to form checkpoint exams. So there's no way you can fail if you're doing those check your understanding, because those are the questions that you will get there. Then these how do you call it, checkpoint exams that you're talking about. Okay, so this one, the first checkpoint exam here covers what, this one, what here, checkpoint, what you have covered in module 1, 2, and 3. Those are the questions that you'll get here. Not for module 4. It's just for this 1, 2, and 3. You get now checkpoint exams. And what are these checkpoint exams? Check your understandings, the one that you have just completed now. For each module, you get those check your understanding. Okay, then you do the checkpoint exams and you just pass that exam. Then you go to 4, 5, 6, 7. Again, checkpoint exams coming in. From where? From check your understandings that you have been doing. The one that you have unlimited attempts. Okay, then you do this. So it's very interactive. So if you want to get motivated, please take those check your understanding quizzes, because those are the checkpoint exams that you'll get here. So it will be just flowing. You can, within seconds, you are through the checkpoint exam, because it's a matter of repeating what you have just already practiced within the check your understanding. You'll do that way, all this until you get now to the final exam. With the final exams, now it is those checkpoint exams. So they'll pick questions from those checkpoint exams that you have been doing. Again, checkpoint exams, you don't have any limits. You can do as many times as possible. All of this. So when it comes to final exams, so you not strain, because there are things that already you have gone through are there. Okay, but remember, before taking the final exams, you'll have to do the end of course survey. The end of course survey is what will unlock the final exam. The moment you take the end of course survey, submit, okay, the course survey is more of the feedback you are giving, your feedback. It's not that exam, but it's a prerequisite. That's why it is locked with the final exam, where Cisco want to know your feedback based on the course content, based on the training delivery based on the trainer Kitoto. Okay, you will get some questions based on me there. So you just submit your honest opinion with things like very satisfied, very dissatisfied, and such. Submit whatever the feedback, okay, based on how you have seen it on this module are there. So that's actually the point that we have. So if you go that way, you'll find this thing very interesting, especially when doing those check your understanding stuff. And also syntax checker for the labs, that is for the labs for practicing. Okay. So that one will be very, very interactive. I downloaded one of the labs here, sorry. This lab I downloaded, so just cancel this. Okay. Then you can see the instruction is not part of it, but it is just with this particular, you can see it's separate. This one, the lab and the instruction. So what you need to do for it to just run alongside this, just click doc. If you click doc here, then it will actually be here. So you have everything in one page. You have the instructions here, you have the lab here. So you just do the lab, okay, as you go through the instructions that are given here. So I believe now I've tried to simplify this, especially those who are still struggling to understand how to access various parts of this. So basically that's what you need to do. Is it clear now? Is it clear, guys? Let me know. Yeah, but don't be afraid. In case you still have challenges, that's why the WhatsApp group was created. Just post it there on the WhatsApp group, your WhatsApp group there. Okay. So I'll be able to respond to it. Or someone who is familiar with what you have posted, feel free also. If you know something that has been posted by your colleague, don't be ashamed, just respond to it and just confirm that it's correct or it's not correct and give the right response to it. So let's be interactive in those groups as well. They're part of, they're just extension of the class that we have. Those WhatsApp group are extension of the class that we have. So let's still interact on those WhatsApp group as well by posting such kind of questions that you feel you're not understanding or any other thing that you feel needed to be resolved. Okay, are there. So that's actually all I wanted to. Okay, that's all I wanted to. Okay. Demonstrate for people who are still asking questions. I think the question has been posted here. Okay. Okay, also when using packet tracer, turn off your Wi-Fi. Yeah, Alphonse, yeah, especially, when your Wi-Fi is on and you launch the packet tracer, for the first time, you will be prompted to log in. You'll be prompted to log in. Okay. When you log in with the green button, skill for all button. Skill for all button, the green button. Then if it's your personal device, you can see the part of remember something. It's 3 months. So you can just slide that button if it's your laptop. But if it's a public device, there's no need. Just leave it the way it is. Okay, so, that means next time when logging in, okay, you'll be able now to just go directly without prompting for passwords. So, but if not, you just switch it off. Switch off. If you switch the Wi-Fi off, it will just launch without prompting you to log in. you just get this page, okay? So maybe you can start by switching off the Wi-Fi or unplug the cable, launch there. If you don't want to keep on logging in, then from there you proceed. So that is that. I can't download Packet Tracer on documentation for Linux. This is Kevin Soy. Kevin, maybe why don't we look at it at the end of this session and be able to see. If you'll be able to share your screen, then we can see the kind of error messages that you're getting there at the end of this session, Kevin. So we can look at it together. You try to download, okay, and I'll be able to see what kind of error messages you are getting. So that's all, guys. So, you know, there are quite a number of lab activities. You might find one module or one chapter has got like 5 or 6 or 7 or 10. So you cannot go through them all. So just pick only, you know, randomly one in each module there and cover them, guys. So now, so I want to introduce the next module, IP4 addressing. IP4 addressing, which is very, very important. You know, we started, if you remember, by, you know, assigning some of those some of those devices with IP addresses. So perhaps people are wondering why that 192, why that 10, how did you get it, and what have you. That's why this part of IP4 addressing is very important. So the main objective in this case for this particular module is to calculate an IP4 subnetting scheme to efficiently segment your network. So basically, we're going to look at the structure of this IP4 address, okay? Then unicast, broadcast, and multicast for IPv4. Then various types of IP4 addresses, and especially the public addresses, the private addresses, the reserved, you know, addresses, network segmentations. Then finally, there'll be subnetting bit of it as the main things that we need to be familiar with. So we all know about IP addresses. The entire IP address is made up of 32 bits. Okay. So IP4 address is 32-bit hierarchical address, which is made up of two parts, the network portions and the host portion. So in that case, we need to understand or determine with these 32 bits that you have been given, which one represent the network, which one represent the what? The host. And that's why those addresses will always have the subnet mask based on the classes they have been derived from. Is it class A? Is it class B? Is it class C? So a subnet mask will be used to determine the network and host portion for that. Okay. Now, and for us to be able to do so, we just need to check what we have, and also in binary. Okay. So we are comparing those number of bits from left to right, as you can see. So 192 to binary, 168 to binary, 10 to binary, 10 to binary. Same thing with subnet mask, 255 to binaries, as you can see here. Okay, so we want to determine which network, again, do a given device belong to. Okay, and the host part of it through a process known as ANDing, the ANDing process. So I want to believe you are a bit familiar with the ANDing process, some of you, or the AND operations. those who did digital electronics, so you understand what we meant by some of these operations, the logic, kind of operations are there. Okay. So now it's always good to be familiar with some of these subnet mask. The default subnet mask is always the first one, 255,000. Expressed in binaries, this is actually what we have, 255,000. So it is an octet where each is 8 bits, 8 bits. So it means we have an 8-bit network address to this 255 being converted as 11111111. Okay, that's the network bits that we have there. We have 255,255,000. Okay, as you can see, again, how it is converted. So we have 16 network bits, 8 plus 8. Okay, the remaining are host bits. Again, we have 16 host bits here. The first one, we have 24 host bits, 8, 8, 8. Those are 24 host bits in class A. Class B, okay? Then we have class C, 255,255,255,0, 8, 8, 8, 24 network bits, okay? With the last octet, which is the host bits, 8, there. So we can see, look at subnet mask and look at the prefix length. It's the same thing. That's why the ISP will get 192.168.1.0 prefix 24, prefix 16, prefix 8, prefix 27. So what is its subnet mask equivalent? Okay. So that's what you need to understand. Now, if you look at this one here, now all these are class C, 128, 192. Okay. So if you look at it, you can see the number of bits that we have. It's just a matter of incrementing what we have. So now we know this is 24, a bit 25, and that bit is here. The last octet, a bit. So 1 is added. 2 is added, 1, 1, 26. So 24, 25, 26. Okay. Then 27, 3 more bits is added. So 24, 25, 26, 27. Okay, yeah. Then 28, 4 more bits are added. 1, 1, 1, 1. So 24, 25, 26, 27, okay, 28. As you move on until you get the last one. So increasing number of bits by 1, 1, 1, 1, 1. And that's what, they have not included it in the first part and second part because of the spacing. But you'll find that this 255, as you can see, if it's full, so you have this one. So again, we'll start again incrementing. So this is 8. This here is 8. So 9, 10, 11, 12, 13, 14, 15, 16, meaning it's full. Okay. If it's full, then move the next one here. 17, 18, 19, 20, 21, 22, 23. Okay, yeah, 23. Then to move to the next one, 24. Until now, to get the last bit. So that's how, those masks, you're playing with those barring the numbers, the ones are there. So you have it in slash notation. That is the prefix. Okay. Count the number of bits in the subnet mask and preend it with a slash. So the same thing are there. So the logical AND, because of the ANDing process that you have talked about, so we just need to look at the 4 ANDing operations, the logical AND Boolean, okay, is either true or false, true, false, yes, no. That's the point. The ANDing means multiplication. Multiplication. So when doing your ANDing, it means you are determining the network address. So somebody can ask you, because some of the common queries that also do arise in certifications. So somebody can ask you, to which network do this do this PC belong to? Admin PC belong to with this particular IP address. Then you have 192.168, maybe .10, maybe .48. .48. Okay. So that means the ANDing operations has to be carried out. It's the only way you'll be able to determine the network address to which it belongs to. So if you look at this, 192.168.10.10, first thing first, convert each to binary, as you can see. For the case, because you'll be given, of course, you'll be given subnet mask and that network. So if you have been given 192.168.10.33 with a mask of 255, 255, 255, 224. Okay? So you have to be smart. There are things which will not change. They just remain the same. And most of the networks, by the way. And that's what is coming up here. Look at this. This 110000, the last one. After ANDing, after multiplying, you get the same results as the first one. Same thing with 168 and 10. So where that 255, 255, 255, you don't expect them to change. The network will not change. But the host bit is what will change. So if at all you want to do such kind of calculations, then your interest should be the last octet, the host bit that you need to convert. Okay. Some you'll even just check, okay, and give the answers on the spot without even calculating. If you are understanding those, the masks are there. So that's how we need to look at it. Then you select the right answers and you move on. So that's how we need to convert it. So you can see with this ANDing operation, and especially the last one, because that's where our interest is. Okay, it's just multiplying 1 times 0, 0 times 0, 0 times 0, 1 times 0, you get zeros. Then back to decimal, the subnet mask. Okay, back to decimal. So you get 192, 168, 10, which you can see has not changed because of 255, 25, 255, then 0. So therefore you can say this PC of yours, 192.168.10.10, belongs to which network? 192.168.10.0. Okay, so that's how we need to determine that the ANDing operations, are there. Then, when talking about unicast, broadcast, and multicast, so it's just how the packets are being transmitted. A good example is what they're giving here. For the case of the unicast, unicast transmission is sending a packet to one destination. Okay, which one are you targeting? A printer, for example. Okay, it's a printer. It's just one way, as they're explaining here. So this is unicast. Unicast. Or if you are in a group, the way you are in a group here, I can just focus with one person here. By calling you, that's unicast. Unicast. I'm calling you with your name, Kibet. Okay? Imani, and such. So it is unicast, unicast. So who is responding, you know? Broadcast is now to all. It's not specific, to all, to each one of you. Good evening, you know, good evening. So I was not specific here. So broadcasting. So broadcasting is such kind of protocol, you know, I mean, being supported by the ARP for the case of IPv4. For mapping, if you remember what we said about, for mapping and for resolving, okay, the IPv4 address to MAC addresses, because I have your IP address, I don't have your MAC address. Broadcast, whose IP address is this? You see, broadcasting, then the right device to respond back, it's mine through now unicast, through unicast. So you broadcast that. For the case of multicast, within a group, you are targeting specific A and B, you and you, okay? You know, Jane and James, you know, and such. So you are very specific. So that's how it do operates. So multicast transmission is sending a packet to a multicast address group. And we have a multicast address for IPv4, as we're going to see it again. Okay, when looking at the categories of classes of IP addresses. So we have those multicast addresses again, that we need to understand are there. Now, each and every IP addresses, they'll be public and private. For the case of IP version 4, not IPv6. IPv6 will be given, is it 3-in-1? Okay, but for the case of IPv4, you'll get private separately, public separately. And these, you know, private IP addresses are meant for internal, you know, identification for our PCs at data that we have. And it means, therefore, when you have been assigned with private addresses, you are not globally routable. You are not globally routable. And that's why now you need a public IP address. So whenever doing the static configuration of DCP, you will find the part of the server somewhere given, where you can now have that address of the server. The alternate server address and the address pattern being given are there. So it means in each class, there is, you know, there is private IP address range. Class A ranging from usually 0. Okay. Allow me to demonstrate it here. I want to expand this a bit. So for class A, ranging from 0 all the way to, okay, all the way to 127, okay, with 0 and 127 being special or reserved addresses. So it means you'll get now the usable one from 1 to 126. 1 to 126, those are the usable one. Zeros can be configured as a default route, 0.0.0.0. 127 is a loopback IP address, 127, okay, .0.0.1. So the range of loopback IP address as well. So those ones we don't, okay, we don't actually use them to assign our address, our devices, okay, with such. So that means, therefore, we are remaining with something to do with the 1 dot something all the way to 126 dot something. So in that range, there is 10, between 1 to 126. In that range, there is 10, block 10. Block 10 is the private IP address. So meaning 1 dot something all the way to 9 dot something is a public IP address for class A. 1 dot something all the way to 9 dot something is a public IP address for class A. So if you get 1 dot, maybe 1.2.1.3, no, so long as it's 1, okay, all the way to 2 dot something, 3 up to 9, public IP address for class A. Then leave out 10 because it's private. Then move to 11. 11 dot something all the way to what? 126 dot something becomes public IP address for class A. That's how we need to differentiate, because we'll be asked. I know there's some activities, and we'll get them within your portal, even in the exams sometimes. Checkpoint exams and, check your understandings. You'll get such, even the final exam for this. So you'll be given a lot of IP addresses. You'll be asked which one is a private IP address, okay? Which one is a public IP address. So it is you to select. So that means you must have a knowledge of differentiating those classes of IP addresses, class A, B, and C. For class C, sorry, for class B, now it is 128, okay, all the way to 191. That's the range for class B address. But which one is the private IP address for class B? For class B, the private IP address here is 172, as you can see, 1600 all the way to 172, 31, 255, 255. Now, I want you to be a bit careful here. Why? Because not all IP addresses that begins with 172 is private. It can be 172, but you are public. Why? The range. Look at the range here. Look at the range. 16 to 31. So it means there is 16, 17, 18, 19, up to 31. So how about if you are 172.15? Are you still in the range of 16 to 31? No. Therefore, you are public IP address. Because of that, you are not within the range. So that's what I want you to check. Not all. Not all. Not all. Okay? So you'll get 172.30.1.1. It is in the range of 1631, so it's a private IP address. You'll get 172, okay, .35.1.1. It's a public IP address. So that's how, especially class B and class C. Leave alone class A. Class A is very straightforward. Class B and class C sometimes is what bring confusion to students. If you look at the range for class C, okay, again here, class C. Class C. It is 192 all the way to 223. 223. Again, same thing as class B. If you look at the range that has been given, let's check that. If you look at the range that has been given, look at the range. 192.168.0.0 all the way to 192.168.255.255. Look at 168. Not all IP addresses that begins with 192 is a private IP address. How about if you get 192.164.1.1? Are you still private IP address? No, they're public. Now that one together now with the rest of the addresses, okay? The rest of the addresses. Now the likes of 193 now become public, 194, 200 or something, 22, and such become now public IP address for class C. That's how we need to differentiate those addresses are there. Okay. I know this an interactive kind of platform on your portal. That now you'll see they'll bring it as maybe which one is routable, which is not routable. Okay. So the one routable is public IP addresses, meaning which one would be allowed to go through, which one would be blocked. So you just need to click on it before it gets to before it disappears. So it's somewhere within your portal. So it's just to help you understand which one is a private and which is a public for each and every class that we have. We have class D, 224, all the way to 239. Multicast range addresses. Multicast addresses. Then you have class E. Class E, 240 all the way to 255. Okay, for experimental or feature use. Okay. But now, you see now we are moving to to IPv6 addresses. Okay. But the usable one always are the first three, A, B, and C. These are the usable addresses that will always be used when assigning, your devices there. So that's actually what I wanted to emphasize so that when you come across such kind of questions, I know you will not have any difficulty differentiating each of those. Okay. We have talked of special use or reserved addresses. Already I've mentioned about loopback address. So you can see the range. So that block of 127.001 all the way to 127.255.255.254 is the loopback IP address. Then link local address. I don't know whether sometimes when you are assigning or the server is assigning the addresses, you end up getting things to do with APIPA. Automatic private IP addressing, APIPA. Now, when you are not being seen on the network, maybe because of the issues, one or the other, the cable issues, or the issue of limitations of the users on the network, automatically you will be assigned with this IP address, anything that starts with the 169, meaning you're not being seen on the network. So there's no way you can communicate. Anything that starts with 169, okay, just note that you're not being seen on the network as a result of maybe cable issues, or you have set the number of users, especially when doing the wireless, you have set the number of users maybe to 5 or 20, and you have added more devices later, but you forgot to adjust. So the servers, the first 20, what will be assigned. The remaining, 169, all of them is a problem. So it's you to go and check how to adjust the number of users or the cable layer 1. Okay, layer 1. They're not being seen on the network. Link local address. So these are more of special IP addresses. And this is what I've been talking about for those classes of IP addresses, class A, B, C, D, and E, as we have said. Okay. All these are what I'm calling classful. Also A, B, and C, classful. Use of default addresses. Use of default addresses. Okay. So later they were replaced with classless addressing. So we used to have those years back. I don't know which years was it. No, where you just have prefix 8 for class A, 16 for class B, 24 for class C. And even subnetting was a challenge because you see, we know very well the number of hosts is millions of hosts that class A can support. And for me, I need only 20. So the rest wastes. Same applies B and C. And that's how they came with, okay, the classless. And that's why you can see now prefix 25 downwards for class C. That's how you can see prefix 9, 10 for class A. That's how you can see prefix 17, 18 for class. Those are now classless coming in. Regardless of what, you can have a class A, the private IP address for class A, 10 or something with a prefix of class C. Okay, so that's the point at there. That's the point at there. So if you look at each of these classes, class A can support up to 16,777,214. Class B can do 65,534. And class C can only do 254 for small businesses, cybers and the rest. Class C, unless maybe you have more than 200, more than whatever computers are there. But with classless, this doesn't matter. You can just have even the other one, so long as you have a prefix for class C are there. Network segmentation. Network segmentation. Segmenting a network. Now, where you are, you know how your network is. Okay. So there are these two terminologies: broadcast domains and collision domains. Broadcast domains is where an area where the traffic can be heard. A good example, all of us were in this meeting. We are in one domain, all of us, and that's why we are communicating. Someone on a different meeting, okay, is not part of us, will not be able to listen to what you're talking about. Another analogy that you can have in place is all of us were in one room. Someone is talking, of course, we'll be able to hear each one of us talking because we are in one room. Separate the group. Group 1, room 1. Group 2, room 2. Those are two different domains. Okay. So meaning, if you want to communicate with someone in room 2, you'll have to get out of room 1, go to room 2, and come back. Okay. So it means in between is a layer. Now a router. Separating the two. Separating the two. So now, as you can see here, all of us belong to one domain. It's all this. So one network. Imagine I don't know how that network will look like. All the branches of a given company or organization for that matter are in one network. Assuming, let's talk of KCB Bank, all the branches, including the headquarters, are in one domain or under one network, So definitely, when an ATM in Nakuru is not working, don't expect the one in Mombasa to work because we're the same network. It's a challenge. It's a network issue, which is very, very risky. Okay? And that's why now we need to separate our network. When there's a congestion, then all the branches will experience the same. It's just one network. Yeah? And we all know switches do propagate broadcast out of all interfaces, all of them. So you'll find a packet or a frame being moved from all the way to Nakuru to Garissa, though it's not concerned with Garissa. One network, that's the challenge with one network. So therefore, the only device that stops all these broadcasts is a router to separate the two, where each router connects now two different domains or broadcast domain, so that in case of any issue, okay, now deal with your own problem. Deal with your own problem. If it's now Nairobi region issue, then Nairobi region sort out the problem. If it is coastal region sort out the problem. If it is western region, sort out the problem. Northeastern region, sort out. You see, because you are now in a different network, not our network. So there's no way we'll be affected with that. So we are separating now the two. So instead of having 400 under one network, 200 on this network, 200 on the other network. So we're trying to reduce all this, okay, through a process known as subnetting. You split the network so that at least each branch now to have their own network. So after, see the example they're giving? So each of these 200 users now will be on separate network, as you can see. And traffic that have been generated on this LAN 1, will not be allowed to go to LAN 2. Deal with their own issues. So meaning engineers, network engineers in this LAN 1 now will sort out their problem because it's their coastal region problem. So they're looking at it as, that side. Unless it's a problem which has originated from the headquarters or is kind of a maintenance. And that's why sometimes, they will actually send a notification if they want to do some maintenance. And usually you can see it, out of business hours at night. Okay? Because now that one affects, all the branches. So why are we subnetting? So as we have said, of course, to improve the network performance. Okay? Then subnetting again on the other hand can help us to implement some of the security policies between the subnets. Okay? So you have your policies on your network, we have our policy on our network. It's possible to set those security policies. Then again, the number of devices that will be affected here will be minimized, reduced, as opposed when we are on one network by the abnormal traffic which have been generated. Okay? So we can subnet based on location. Okay, we can subnet based on location, maybe floors, floor 1, 2, 3. Based on group or functions, maybe administration subnet separately, HR network separately, accounting separately, students separately, etc. Based on the device type, you have those intermediary devices and the end devices. Maybe, again, the kind of networks are not the same. That's how you can base your subnetting. Okay. How do we subnet a network? How do we subnet? Depending on the class that you have, the concept is very simple. And by the way, when subnetting, and also for the beginners, those who are not familiar with subnetting, for you to be guided properly, whenever doing subnetting, there are 5 key questions that you need to ask yourself as you do your subnetting. As you do your subnetting. I can now wrap this. So you can talk of five key questions. To consider while subnetting. Okay. No, it's not within the actually the portal or within your notes, huh? But it's something we thought of just to summarize the topic of subnetting, because I know those who did networking units, if at all you came across subnetting topic, perhaps maybe it gave you some headache. Huh? But what I'm saying, there are 5 key things that you need to consider while doing your subnetting. Number 1, okay, how many subnets, because you want to do subnets, how many subnets are created? How many subnets are created? Okay. How many subnets, okay, are created? Formula, number of subnets equal to raised to power x, superscript. Why is superscript? It is here, superscript. Okay. Raised to power x, where x are bits borrowed. Where x are bits borrowed. Okay. B. Yes, you have your subnets. It's like having your branches. It's like having your branches or departments or something. So with those your branches or departments, each will accommodating how many hosts? So number of hosts per subnet. Number of hosts per subnet. Okay. Formula 2 raised to y minus 2. Okay. 2 gives you number of hosts. Number of hosts. Okay, superscript this. Okay. Where y are bits remaining. So remember, you are dealing with the number of bits. If it's class C, it's octet, the host bits. It is 255, 255, 255, 0. That 0 is an octet, 8 bits. So you are dealing with 8 bits. Borrowed 1, remaining 7. Borrowed 2, remaining 6. Okay? So the remaining one is what will help you to calculate the number of subnets. I mean, the number of hosts. The number of hosts. C, valid subnets. Valid subnets. Okay. Back to A. Which are these subnets you have created? So we need to list those subnets that you have created. And for us to be able to know this number of subnets that you have created, we need also to understand what are calling the incremental value, the block size. The block size. You have the starting point, yes. Where is your ending point? Okay, meaning if you are assigned a Nakuru branch with a given subnet, so they will end where? Okay, where will they end? Then their ending point mark the beginning of another branch. Block size. Block size. So you need to understand your block size. So your block size is the magic number, okay, minus the subnet mask. Minus the subnet mask. So we need to understand that. Okay. Then D, we are talking of valid hosts. Valid hosts. Meaning, not all IP addresses will be what? Will be usable. So it means there is also what? Broadcast in each. It means there is broadcast in each. Broadcast per subnet. Broadcast per subnet is there. So if you are to go through these 5 questions, no, it will guide you. It will guide you, and also for the beginners, those who are still, digesting the concept of subnetting. This will guide you at least to understand. It's like a baby, to understand how subnetting is being carried out there. Example. Subnet 192.168.10 prefix 26. Okay. You know, the ISP will just give you the entire block. Default prefix 24 for the case of class C. Prefix 8 for the case of class A. Prefix 16 for the case of class B. So it is you as a team, the engineers, the department, the ICT office, to decide how you want to carry out the subnets based on the branches or the departments that you have. So this is a class C address. We know class C is prefix 24. So for me to answer the first question there, number of subnets, I just need to ask myself the bits which have been borrowed. And when talking of bits borrowed and remaining, look at it in terms of binaries. Binaries. Okay? Look at it in terms of binaries. If you said one bit is borrowed, then it is 1 and 7 zeros. 1, 2, 3, 4, 5, 6, 7. I'm giving example. If you said 2 bits borrowed, it is just 26 minus 24 because these are class C. Those are 2 bits. How do you write it? You don't write 2 that way. No, you write 1, 1. Then 6. 1, 2, 3, 4, 5, 6. For them to be 8. If you said 3 bits borrowed, 3 bits borrowed, okay, it is 1, 1, 1, 1. Remaining 1, 1, 1, 1, 1. 5 of them, huh? 5. That's how simple it will be. So look at it in terms of, look at it in terms of binaries. In terms of binary. Okay, are there. So it will help you to go through it. Okay, so to answer the first question, how many subnets are created? You see, the default one, okay, here I'm supposed to have 24 as the default. Then, sometimes these questions do come in form of applications, the exams. Okay, so maybe we'll get to those questions. So they're there, even on your portal, you'll be able to see them. So now, because this is a class C, we know class C is 24, and now this is 26. So those are 2 bits. So 2 raised to power here, number of subnets, where X are bits borrowed. So those are 2 bits. So 2 raised to power 2. 2 raised to power 2. What is that? 2 raised to power 2. What is 2 raised to power 2? Let's be interactive. Yes. Peter, yes. 4. 4. Yes. 4. Those are 4 subnets. Those are 4 subnets that have been created. Those are 4 subnets that have been created. Okay. So I have my 4 subnets, meaning I have my 4 branches. In other words, when you look at it in terms of branches, look at it in terms of departments. So you can split that network 192.168.10.0 prefix 24 into 4 more networks there. Okay, so now you know very well we have talked of borrowed bits. So 2 were borrowed, okay, as particularly what I had given there. Okay, 2 were borrowed. 2 were borrowed. I can write it here just to explain it further. 2 were borrowed. 1, 1. So remaining 1, 2, 3, 4, 5. So remaining are 5. So to get the number of hosts that each of these subnets will accommodate, B, it is 2 raised to y minus 2, where y are bits remaining. So 2 raised to 5 minus 2. What is 2 raised to 5? That is 2 raised to 5 is 2 times 2 times 2 times 2 times 2, 5 times. 2 times 2 times 2 times 2 times 2, 5 times. Huh? What is that? 32. Okay. Then minus 2, because it's 2 raised to 5 minus 2. Minus 2, you have your hosts, 30, correct. 30. So 30 hosts. 30 hosts. So each of these four will carry 30, 30, 30, 30. Rukana branch, 30 computers. Garissa branch, 30 computers. Mombasa branch, 30 computers. Okay? Kakamega branch, 30 computers. That's how we are looking at it. Huh? Okay? So you are trying to, because you see, you want them to accommodate those subnets that you have created. Even if they don't have 30 hosts, let's say like Turkana branch, even if you give 20 or 15, still there's more room for expansion, because you see there are some addresses which will be unused. So you can even add more later. Okay. Then now see valid subnets. Now you're telling us you have 4 subnets. So the question in C, which are these subnets? Can you list them? That's the question. Can you list these subnets so that we can see, oh, this, and this, and this? So you take your block, as you have said, your block size. So magic number. So it is 256, which is the magic number. But their magic number is always a 250. It's a value of 256 minus your subnet mask. Where is your subnet mask? Where is your subnet mask? Very simple. Subnet mask is what is borrowed plus what is remaining. Here, you borrowed 2, remaining 5. So you convert this to decimal. So if you go to your calculator, go to your calculator, if you go to your calculator, then take the programmer, oh, it is there. The programmer calculator, you have scientific standard, take the programmer calculator, then have binary, click on binary here, then it is 1, 1, and 5 zeros. 1, 2, 3, 4, 5. Okay. Is it this is 1? No, 6 zeros. Is it 6? 6 zeros. Sorry for that. It is 6 zeros. It is 6 zeros, not 5. Huh? So if you do so, what is your value in binary? In decimal, it is here. So in hexadecimal, it is C0. In decimal, it is 192. In octet, it is 300. You know, binary is this. Huh? So that's your number. So it is 192. So you subtract that. Huh? You subtract 256 from 192. And you get what? You get, what do you get? Is it 64? Yeah, 64, right? It is 64. 256 minus 192, 64. Okay. So this 64 is the block size. Is the block size. And therefore, remember, you are given the first address by the ISP. So it is included. It is included 192.168, sorry, .168 dot 10 dot 0. Okay, it was prefix 26. This is the first one. Now, in class C, your interest octet is the last octet. So remember, the first 3 255 are full. 255, 255, 255 are full. Dot 0. So the last block 0 is what will be incremented. So this 0 here. So it means the next one will be, okay, so 0 plus 64. 0 plus 64, you get 64 here. Okay, you see, you are moving with the blocks of 64, 64, 64, 64. Okay, 0 plus 64, 64. 64 plus 64, okay, the next one here. 64 plus 64 is 128. Okay, 128 plus 64, okay, it is 128, 64, that is 12, 8, 9, 192. 192. So there are 4. 1, 2, 3, 4. Valid subnets. Valid subnets here. Valid subnets here. So which are these valid subnets? So this is what now we need to distribute. HQ can have the first one. Another branch can have the second one. Another branch, you can have this one. Another branch, you can have this one. So there are 4. There are 4. Then, for you to get now valid host and broadcast per subnet, let's come up with a table, kind of, here, a table. This our table will be having how many columns? We have columns for subnets, column for first host, last host, broadcast. There are 4. 4. So insert table. So I need 4 columns. Okay. And some rows. So I can just, I'll be adding. Let me just have that. Then here I'll have subnets. Then first host here, last host here, broadcast per subnet. So the first one, I can have this now, all of them cut and have them here, paste. Okay. Therefore, yes, 1, 2, 3, 4. Yes. Then, so in each branch or in each subnet, how do you want to distribute your devices? Like which one will be for the router interfaces, which one will be for the servers, and what have you. Whether it is through static or DCP, it's possible, so long as you have identified the subnet. So in that case, what is the first usable host here, if I may ask? What is the first usable host here on this network? When assigning, 0 is the network. The first one will be, yes, 1. 1. So 1 here. 1. On this network. So 10.1. And by the way, in the labs that you will encounter, because you have labs for subnetting, in the labs that you will encounter, okay, let me push it to the next. In the labs that you have there, you'll get this kind of things, this kind of tables, and the instructions. Assign the first usable host in subnet 0 to the router interface. Assign the second usable or the second last. Assign the second last IP address in subnet 0 to the CCTV camera and such, you know. So that's how they'll be distributed. Now, what's going to be your last address here? The last host address will be 63. Willimo, 63. Good trial. Good trial. Who else can guess the last usable host? 62. 62. Okay. Okay. Let's see. Alana, Philemon. Okay. Let's see. What did we say is our here? Here. I don't know whether we did this one correctly. How do you get the number of hosts? It was 2. Oh, 1, 2, 3, 4, 5. Sorry, I have misled you. There's supposed to be 6. These are 5 zeros, right? 1, 2, 3, 4, 5, 6. Yeah, it was 2 raised to power 6 minus 2. Sorry, guys. Sorry for that. So, which is 62, correct? Sorry for that. Sorry for that. So it is 62. It is 62. Okay. So remember, we are saying host per subnet. Host per subnet. What does that mean? It means, guys, that the last host, you cannot go beyond what can be accommodated in each subnet. So it is per subnet. So 62 plus 0. 62 plus 64. 62 plus 128. 62 plus 102. Remember, these are subnets. Because it is host per subnet. That's how we get the last host. So here you'll get, okay. I need to expand this. I need to expand this a bit. I need to expand this. Okay. Why is that? The other part. Okay. Control Z to undo. Sorry. Yeah. So the last host is 62. 62. Okay. Then what is your broadcast? What is your broadcast? What is your broadcast? What is your broadcast? Sorry, I'm trying to manage this. Okay, 63. The broadcast, very good, 63. The broadcast is the last number before you jump to the next network. So 63, 64 down here. 63, 64. 64 is the next network. So broadcast is the last number before you jump to the next network. So your broadcast in this case now will be 63. Yeah. Okay. Will be that 63. Now, in a given network, in a given branch, you want to find out which devices are communicating, which one are reachable, because they'll be responding. So instead of doing one computer at a time, you ping 192.168.10.1, you ping 192.168.10.2, you ping 192.168.10.3, all the way to 62. It will be very tiresome. That's why broadcast is there. Just ping 192.168.10.63. All these computers, number 1, number 2, number 3, up to 62, will reply, all of them. That's the purpose of the broadcast. You just ping the broadcast, all of them will reply. So on your list, you can check between 1 to 62, which one have not replied here. So if you can tell someone, you computer number 20, sijaona kwa hii list, mona reply, the rest are replying, he reply. So it means it's either it's off or there's a problem that, so that's your role as a technician or engineer to find out why is it not responding, yet the rest are responding. That's the purpose of broadcast address there. Then you move now to the next one, network 64. So the first usable host here will be 60. What is the first usable host? What is the first usable host? Because 64 is the network. So the first usable host will be 65, correct, 65. On this network, remember, maybe this is Turkana. So if this is the subnet you have given to Turkana, so wow, wataanza from 65. They will not start from 1. This kind of subnetting you are doing is fixed subnetting. Fixed subnetting, meaning each subnet will have the same prefix length. Because we have just splitted it into 4. It's just one network being splitted into 4. Okay. What is your last host here? 120, 125, 126, 126, 126. So it is, it is 64. Remember, it's subnet, 64 plus 62. 64 plus 62, 120. So that's give you 126. Okay. What is your broadcast? Let me just push this a bit. What is your broadcast here? The broadcast will be 127. 127. Before you jump to the next network, 128. Okay. So what is your first usable address in 128 here? Would be 120, 129. Okay. What is your last host? Okay. What is your last host? What is your last host here? Okay. 190, correct. 190. What is your broadcast here? What is your broadcast here? 191, correct. Okay, what is the first usable IP address here in 192 network? 193, correct. What is the last? Okay. What is the last one? The last will be 254. 254, correct. 254. Remember, it is 102 plus 62. Okay, 254. What is your broadcast here? What is your broadcast here? 255, correct. 255, correct. Because the next one is 256, magic number. So the last one will always be 255, a broadcast. So you can see in each subnet is broadcast. So if you want the devices within the network 192.168.10.192 to communicate, then just take the broadcast 192.168.10.255. Just ping you all of them, 192 all the way to 254, will be replying. Then you confirm which one has not replied. Then you start your troubleshooting from there, because all of them in that range are supposed to reply. Now, if you look at those labs of subnetting, you'll find that you'll get this kind of things. But then this is the same thing that you'll be getting. Then they'll ask you, based on that, how to assign those addresses. So after each subnet, they can ask you with more instructions, assign the third last address on the 128 subnet to admin PC. So what is your third last subnet on 128 network? What is your third last subnet on 128 network? Mm-hmm. 188. Okay, 188. So you'll be assigning 192.168.10.188 and such. So very interesting if you get the concept. So I want you to keep on practicing this so that at least you get to understand how these subnettings are being, performed. They're very simple things, by the way, not hard. Okay, not hard. You have to summarize this. So this is a table referring now to the subnetting for class C, prefix 24. Okay, prefix 24, as you can see here. So 24, 25, 26 up to 30. Okay, with their subnet mask and the subnets for each that have been created against the host that each can accommodate, as you can see. The fewer the subnets, the higher the number of hosts. The higher the subnets, the fewer the hosts. Okay, as you can see. So this now summarizing all the prefixes. So the one that we have been handling the 26. So you can try 25, 27, 28, using the same 5 questions I've given you to see how far you can go with it. Where there's a challenge, let me know. Okay, or post it in the group. I'll be able to help you out. So now, to meet the requirements as winding up here, so subnet to meet requirements. So subnet private versus public address space. So remember, all the devices that you have in your network and how they'll be assigned. We have intranetwork, of course, this is the internal network that will be used with private IP addresses. We have other DMZ, delimitarized zone, where actually you have the servers located. Okay, most of the servers will have the public IP address there. Okay, so that's the thing that we need to understand whenever doing. So which one needs public IP address? Which one needs private IP addresses? So now this one is just explaining the 2 considerations when planning subnets: the number of host addresses required for each network, the number of individual subnets needed. Okay, as we have said there. Just to summarize that part. Then, as already stated, I'm just, we're just reviewing what already we have covered. So you can see with the subnetting, so you just need to check the branches. Sometimes, you want maybe to influence how the devices will be allocated. So each branch 1, wapatie 25. Okay, 40. Another branch, in that order. So when doing subnetting, ensure that it will align with those devices that you have given there. So it's always safer to leave room for more expansion than giving the fixed where if someone now is adding more, there's no room. There are no more addresses. So it forced you to go to that branch and split further that subnet. Okay, subnetting a subnet. You are splitting it further to accommodate more devices that you have added. So it's always advisable to be the safer side, always leave some room for expansions are there. Now, unfortunately, what you have done now, that fixed subnetting is not what is being used today. But I was just covering it for the sake of what? For the sake of, guys, for the sake of exams. What is applicable today is VLSM, variable length subnet masking, is what is applicable today. Okay, as the name suggests. You see, with the example that you have given, all of them are sharing the same what? Subnets. Right from the first subnet to the last subnet. All of them are prefix 26, 26, 26, 26. So it means each branch will have the same subnet mask. Different networks, same mask, which is okay. Different subnets, same subnet mask. Very okay. But now, in that case, we want to, come up with another way where there'll be different subnets with different masks. So we call it VLSM. So they vary. Oops. Oh, sorry, guys. Okay. So for example, you're being told, given the topology, 7 subnets are required. That is 4 LANs. That is 1, 2, 3, 4. And 3 WAN links. Okay, that is the connection between R1 and R2 is one network. R2 and R3 is one network. R3 and R4 is one network. So 4 plus 3, total 7. And the largest number of hosts is in building D with 28 hosts. Where's that building D? Building, yeah, here. Okay. So therefore, in that case, a prefix 27 mask will provide 8 subnets of 30 hosts. 30 hosts. Okay, and therefore support this topology. So that's how again we look at it, because you see this is 7. So it means that different subnets 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7. 7. And you see, when doing your subnetting, it is not a must to get the exact. It's better to get one more extra than getting less. So you are comfortable with the 8 subnets than maybe 6, because just do 2 raised to this number of bits borrowed, 2 raised to 2, 2 raised to 3, 4, 5. You'll find that there's no 7 anywhere. There's no 7 anywhere. Okay. If I may take you back, there's no 7. You can see it is 2, 4, 8, 16, 32, 64. For class A, B, and C, hakuna 7. And you cannot go for 4 sub audible? Okay. Okay. No, my screen disappeared. Are you able to see my screen? Are you able to see my screen? Okay, thank you. Thank you. So now in this case, so you can see, let's look at this or work with this scenario where you have prefix 27, and we know point to point, but the point to point, like you see R1 and R2. Now remember, the hosts are not the PCs alone. Anything that you are assigning with the IP address, including the port number, become the host. So that means between R1 and R2, this port of R1 is 1, this port of R2 is 1. So there are two hosts here. And what is prefix 27 giving you? Okay. What is prefix 27 giving you? Prefix 27, in terms of hosts, is giving you 30 hosts, as we have seen. 30 hosts. And here, you see, the only number of hosts that can be accommodated is 2. So 30 minus 2, 28. So meaning you have 28 here, remaining, 28 here, remaining, 28 here, remaining. So 28 times 3, 28 times 3, you have 84 unused or wasted addresses for the point-to-point. That's why that traditional subnetting, we call it, the one that we have just covered, we call it traditional subnetting, okay, legacy subnetting, because of the wastes that it has. So for us now to minimize all these wastes, we're now introducing VLSM. So VLSM was developed to avoid wasting addresses by enabling us to subnet a subnet. You subnet a subnet. You go to a branch, okay, because you cannot go back to ISP again, say we want another subnet. So you can split that subnet further to accommodate more devices which are coming in. Possible. Okay. So in that case, that's what we need to look at it. So, and that's what they're trying to apply here. By now, splitting one subnet again. Okay. So you can see one of this segment has been further subdivided, meaning we want to create more subnet out of it to get that. So if you look at it, we find that now it has a different prefix 30. Prefix 30 can accommodate two hosts. By the way, it's important to understand each prefix and the number of hosts that it can accommodate. If you get to understand that, then the rest will just flow. What do you know about prefix 25? What do you know about prefix 17? What do you know about prefix? We used to play with those kind of things. Okay. So you look at it in terms of number of subnets, the number of hosts. Number of subnets, number of hosts that it can accommodate. Just like what I've shown you here. Sorry for that. What do you know about prefix 25? It has 2 subnets and it can accommodate 126 hosts. What do you know about prefix 30? It has 64 subnets and it can accommodate 2 hosts in each subnet. Okay. So that's the secret behind all this thing. Okay. So that's what they're trying to explain by further subnetting that. So I'll give more example later for VLSM, maybe tomorrow I'll give, so that we'll be able to differentiate between traditional subnetting, or what I'm calling classful subnetting, and class subnetting. I'll give that one. So for now, just to wind up this part, the planning, when doing your address planning, okay? So of course, you have to sit down and plan if at all you want to do a subnet with your team. As the head, sit down with your team and do a plan, how you want subnetting to be executed, because you must work as a team. And why do you want to do subnetting? Okay, the planning. Why do you want to do that subnetting? What is the need for that subnetting? Perform a network requirement study by looking at the entire network to determine how each area will be segmented or subnetted. To segment and to subnet. The two terms are being used interchangeably. Determine how subnets are needed and how many subnets per subnet. Then determine the GCP address pool and layer 2 VLAN pools, those pools that you're going to create. So a pool could be a branch. This branch is pool 1. This branch is pool 2. This pool 3. Okay. If you have VLANs, again, be ready with the VLANs, because VLANs will have their own what? Subnets. So again, can subnet that one is possible, if at all you have VLANs that have been created within your network. Then assignment of these devices with the addresses, yes, after you have done so, so you need to know in each subnet, the one which have been used, the one which are available. So you know which are available, which addresses are available. So all these devices, end user clients, will require these addresses. And by the way, if you pick a pool, you can now set the DHCP for that pool. I'll explain how that is possible. For that pool, you take that pool. Servers and peripherals, yes, also. Mostly, devices which are not being moved on the network, they are static. Like printer is just always there. Okay? Those ones, you can just do static IP addressing. No need of automatic. Servers that are accessible from the internet. Servers must have a public IP4 address. Okay? So sometimes, if not, you can have NAT. We shall talk about NAT later in CCNA3. Intermediary devices, yes, these are routers and switches as well, also need to be assigned with addresses. So the highest, the lowest addresses. So you might find things like the intermediary device like router, first usable addresses in each subnet are being assigned with this, maybe 10.1, 20.1, 128.1, 192.1, and such. Gateway, routers, and firewalls, okay, also needed to be assigned with addresses. So when developing this your plan, it's always recommended you have a set pattern of how those addresses will be allocated. You don't just assign for the sake of it. So there's a formula. And that will help you to understand how devices have been assigned, which are usable, which are not usable. So you know you have them somewhere. Okay. So thank you guys for your time. That's marked the end of today's presentation. Tomorrow, we are going to still continue subnetting on VLSM, the most practical one being used today, not the other one. The other one, for the sake of the exams, just go through it, understand it, okay? But the one which is more practical, and as you'll be able to see, now we'll do it tomorrow, VLSM, subnetting. Very simple and very straightforward. So that's marked the end of that. Let me see whether there's some questions that okay. Now subnetting and segmenting. Okay, they're more or less the same thing, as I've said. They're being used interchangeably because this is the issue of just dividing, okay, the network or separating, segment to separate. And where each separations there is a subnet, a subnet, a subnet. And also, how does a router perform subnetting in case of equipment failure? And okay, we'll talk about how to enable a router perform this. Remember, you're going to create pools on the routers. How many ports do you have on a router? 2 ports. So each port is a pool. So after you have done, remember, it is you subnetting first. After you have subnetted, so you configure as per the pools, as per the interfaces that you have there. Okay. And routers don't what is the question? Failure and display allocate IP address for the switches without broadcasting. So routers break the domains. Routers will not allow broadcast to go through it. That's why a router is being used. And layer 3 devices now come in between. Only layer 2 devices, that's now the switches, will tolerate or allow this broadcasting. But when they get to switch, they'll be blocked. Now, the only thing that we can configure, let's say if you have a server in Nairobi, you have a server, DHCP server in Nairobi, that is assigning the addresses in Nakuru, that one will configure what I'm calling a relay. It will relay the request. Okay, that's another level. I think CCNA 2 or 3 will actually, it is there. We'll actually look at it. So you configure a relay. You configure a relay. Yeah, I think that's all. I can't see any other question. Okay, guys, thank you so much for your time. Let's meet tomorrow with more details.